Now that we have the Create page working, let's test the Edit page. I'll open up this existing expense, and let's change all the values of these fields to make sure that the record is updating properly in the database. I'll change each of the values, so we'll know if an individual field didn't update. I don't need to change the expense category, because that doesn't get saved to the database. It's just used to filter the expense type list. Okay, now let's save these changes. When the record is saved, the page redirects to the list of expenses, and we can see the values have changed for the record. The date is updated, along with the expense type, description, location, but the price is showing 0. That's not what we entered, so there's something going on here. Let's go into the code and up to Solution Explorer. I'll clear the last search, and the Pages folder is open. That's where the Create page was, and the Edit page is a little farther down. So let's open that up. And it looks pretty similar to what you saw on the Create page. There's this expense property, which is bound to the CS.html page. And farther down, there's a method onPostAsync. It's structured pretty much the same. So since we saw how the expense is populated on the Create page, and we've already debugged an issue there, we know that we might be looking at the same cause for a different issue. I'll set a breakpoint here, and let's go back to the running app and edit the page again. I'll update the price, and let's save this. The breakpoint is hit on the Edit page, so this method is handling the Save button click on the server side. Let's step through the code with F10, and before we send the new expense to the repository class, let's hover over the object and check out the values of its properties. And the price is 0 here. If we look at the try_update_model_async method just above, we can see already that the price property is missing from this list. Of course, if we didn't have the previous experience of debugging the exception where the expense type ID was missing, we could use the same approach to debug this problem, but we'd have to understand where the button click is being handled in the server-side code, because we didn't start with an exception this time. But you can see this is where debugging starts to build up your knowledge of what can go wrong in an application. If a mistake was made somewhere, there's a chance the same type of mistake can show up in other places. Let's add that property and run the app again. When the app starts, let's navigate to the same expense and try and update the price field again. The breakpoint is still active, so let's step through the code and make sure we're seeing the price updated in the object that's being sent to the database. And now it is. So I'll click Continue and let the application run. When the page redirects, the price field has now been updated. So we saw the same type of fix to what at first appeared to be a different problem. There was no exception in this case. The application just didn't behave the way we expected it to. And because of our experience debugging this application, we had a sense of where to look, because debugging helped us to gain a better understanding of the structure of this application. By debugging and stepping through the code, we learned that the page's code behind transforms some data and calls another class to save the data. At this point, you might research some of the things you saw in the application and ask why it's being done this way. This isn't a course about ASP.NET, but I'm intentionally not using simple examples here. We're using an enterprise-type application because you'll get dropped into applications in your career that you may not understand, and debugging will help you learn how the application works. But let me explain the structure a bit. First, why isn't the code just passing the expense object that's being populated from the page right to the repository to save into the database? And second, why is the code not just calling the entity framework right from here in the code behind? Why does this need to be so complicated? Well, enterprise applications often go beyond simple design because of things like security and testability. The reason this try_update_model_async is used is so a malicious user can't pass hidden values over HTTP. There might be a certain field that you don't want the code to update, but if you just take whatever is sent from the browser and save it to the database, you're trusting the user input when you shouldn't. And the reason the entity framework code is being kept in a different class is for testability. Unit tests can use a mock version of the repository that doesn't actually call the database. It just returns the same values from the code each time. That allows you to only test this class in a unit test without testing all the way to the database. You're going to learn about unit testing later in this path on C# programming. For now, you've successfully debugged an error in an ASP.NET Web application. Next, let's talk more about some of the benefits of debugging before we move on to more advanced topics in the next module.